Hello everyone, I'm Siriji from Sri Venkateshwara College of Engineering, studying in 6th SEM, Department of Computer Science and Engineering. I'm here to discuss about the topic Machine Reference Model. Machine Reference Model. Virtualizing an execution environment at different level of the computing stack requires a reference model that defines the interface between the level of abstraction which hide implementation detail. From this perspective, virtualization technique actually replace one of the layers and intercept the calls that are directed towards it. When an execution environment is virtualized at unlike level of the stack of computation, then it requires a reference model which defines the interface within the level of abstraction, and this level of abstraction hides the details of implementation. This projects an idea that virtualization techniques can substitute any one of the layer and can intercept the calls which are directed to it. That's why a clear separation within the layers can simplify their implementations, which only need an emulation of the interface and a proper response with the underlying layer. Modern computing system can be expressed in terms of reference model described in the figure. At the bottom layer, the model for the hardware is expressed in terms of instruction set architecture. Instruction set architecture is also known as ISA. Instruction set architecture defines the instruction set for the processor, register, memory, and interrupt management. It is an interface between software and hardware, and it is mandatory for the operating system developers of application who directly manage core hardware. The operating system layer is separated by the application binary interface from the application and libraries which are managed by the operating system. Next, application binary interface. Application binary interface is also known as ABI. Application binary interface separates the operating system layer from the application and libraries which are managed by the OS. Application binary interface covers details such as low-level data types, alignment, and call conventions, and defines a format for executable program. System calls are defined at this level. This interface allows portability of applications and libraries across operating systems that implement the same application binary interface. The highest level of abstraction is represented by the application programming interface, which interface application to libraries and/or the underlying operating system. Application programming interface, also known as API. The instruction set exposed by the hardware has been divided into different security classes that define who can operate with them. The first distinction can be made between privileged and non-privileged instruction. Non-privileged instruction are those instructions that can be used without interfering with other tasks because they do not access shared resource. This category contains, for example, all the floating, fixed, and arithmetic instruction. Privileged instructions are those that are executed under specific restriction and are mostly used for sensitive operation, which expose or modify the privileged state. For instance, behavior-sensitive instructions are those that operate on the input-output, whereas control-sensitive instructions alter the state of the CPU register. Mainly, the CPU runs on two privilege levels. User mode. In this mode, memory access is restricted up to some limit, whereas access to the peripherals is denied. Kernel mode. In this mode, the CPU has instructions that manage memory and how to be accessed, and it also has the instruction that enable access to the peripherals like disk and network card. From one running program to another running program, the CPU switches automatically. The expansion and packages of computing gadgets are simplified through this layered approach. The application of multitasking and co-lifestyles of more than one executing is simplified through this layered approach. The first can be made within privileged and non-privileged instruction. Those instructions which can be used with interrupting with another task are known as non-privileged instruction. The instructions which are executed under particular restriction and which are frequently used for sensitive operation, which expose behavior sensitive or modify control sensitive, are known as privileged instruction. A possible implementation features a hierarchy of privileges in the form of ring-based security. Ring 0, Ring 1, Ring 2, and Ring 3. Ring 0 is the most privileged level and Ring 3 in the least privileged level. Ring 0 is used by the kernel of the OS. Ring 1 and 2 are used by the OS level service, and Ring 3 is used by the user. Recent systems support only two levels, with Ring 0 for supervisor mode and Ring 3 for user mode. All the current systems support at least two different execution modes, supervisor mode and user mode. The first mode denotes an execution mode in which instruction, privileged and non-privileged, can be executed without any restriction. This mode, also called as master mode or kernel mode, is generally used by the operating system or the hypervisor to perform sensitive operation on hardware level resource. In user mode, there are restrictions to control the machine level resource. If code running in user mode invokes the privileged instruction, hardware interrupts occur and trap the potentially harmful execution of the instruction. Conceptually, the hypervisor runs the above supervisor mode. And this is all about machine reference model. Thank you.